Hi there, this is Milosoft, Commodore 64 and Commodore PET programmer, game creator, and just regular enthusiast. In this video, I've decided rather than create a whole bunch of small videos, I was just going to put together one huge video where we go through games A through Z. So there will be 26 games that will be cracked or deprotected. And by the end of this, you should have a very good idea of how to do it if you have your own games, or just reminisce. A lot of the comments on my YouTube channel are from people who just remember the old days, and they just enjoy reliving it, even if they don't want to actually get into the hands-on process of cracking. So we're going to start with A this time, obviously, first letter of the alphabet. And this is going to be Advanced Art Studio, which is a utility. Rainbird Software presents. Please type in the 11th word that appears on page 43, line 5. So there is no copy protection as far as errors go, but there is a password. I will be using CCS64 emulator and the built-in monitor, which is accessed by the Alt and M key if you want to play along. Otherwise, you can use Vice emulator or a real 64 with a monitor cartridge installed, or a freeze cartridge. So what we do is we go into the monitor, and I'm just going to hunt from 0 to FFFF using the H command for the opcodes E4FF. E4FF points to the kernel routine, which is FFE4, to read a key from the keyboard. Let's see if we can find an introduction into the program where it starts. Here's the load routine in 0300. It's setting the screen to white. We open a channel to the drive. FFBD, which does, it looks like it's getting set up for the file name, 37D, 37E. We're just concerned with the main jump, which appears to be 4720. And sure enough, so I'm just going to freeze, go into 4720. We have a JSR to C04F. This turns the screen black. JSR C044. Jump BEA6. Not sure what we're doing here. Let's hunt in the C1000 bank for E4FF. We have two results. You'll notice that if you disassemble on a particular address, it comes up as garbage. That's because you're searching in the middle of an opcode, like when you should be here, but you're actually here. So that's why I back up and I just scroll down. GSR FFE4, clear out 200. Let's try a different approach here. Oh, that's resetting. So we got it wrong. Okay. Well, we know what it does if you get the password wrong. Assuming that you get 3 tries, I'm going to search for a compare 03. Increment 5C, compare it to 3. So if you get a certain number of tries to get a password, what you can do is you can try searching for a compare, like I did, C903. So I searched for C903, hoping that somewhere in here it would find the counter, and I think I found it. So let's just check what 5C is. 5C is 0. 5C is 1. Get it wrong again. 5C is now 2. See how easy that was? We just hunted in C1000 for compare 3 and found it right there. So now what it does, if you get your 3 tries, is it loads COF4, Y, stores in O200 and jumps to 200. And this being COF4, it's filling 5800. 5800 is set right here with 0, and 59 is set to 04. So indirect addressing, it's basically saying store 0400. And then it increments 59, so it goes 0500, 0600. It's destroying itself in memory. We're getting there. So we're just going to backtrace it. COD2 is if you get it wrong, which is going to be right here. Load 58 compared to OF, branch not equal COD2. And we get it wrong. Increment tries. 3 tries. No, it goes back up to CO5B. Otherwise, white memory. So we need to prevent it from going to COD2. That happens right here. And right here. And when it's finished, it does an RTS. Let's just see what's at 58. At 58, we have C2F2, DXH. It's probably my password. All right, let's make this easy. At COC2, we'll put an RTS. And it's done. 1 single byte at COC2. Just to go through that quickly for those of you who are wondering what. So you had 3 tries before it kicked you out. So I hunted in C1000 for C903, which is compare 03. Those are the opcodes. Now there are other places this does appear, but with that JSR to C in the C1000 area at the very start of the program, I figured it was here. We then checked 5C, which kept incrementing every time we got one wrong. And then we saw the self-destruction of memory. So it's loading 58, Y, comparing it to what's in E, incrementing Y, so it pushes over 1, compares it to F. E and F should have 0002. I have no idea what that would be for a password, but I do know that just at COC2, all we have to do is put a 60 RTS, because that's what it does at the very end of the protection check. Just put anything in, and you're done. So now we have to find out where the file is. I would imagine it's in main. We'll see. Yeah, so COC2, there we are. Going to use my famous approach of filling memory up with stars, with the purpose of finding out exactly what area of memory the program occupies. We know it doesn't touch this area here, and we know now it starts at 4720 because it overwrote my stars to C4, 4C. So we're going to figure out what the file name was, main. We're going to save main from 4720 to C44D, 1 extra byte. We're using 2D and 2E to figure out what the end address is. Those two values get set every time you load something, and it's the end of the program pointer. So that's why I know where it ends, and we know where it starts. So that is done. I'm now going to just pause and switch over to another app. Now we're going to load in the original disk, Advanced Art Studio. I'm going to delete the old main file. I'm going to import the new one, which is going to be in my CCS directory. Going to put it in lowercase. Save. So what I did was I just deleted the old file and imported the new one that I had saved from the CCS emulator. I'm going to do a hard reset and see if it is now cracked. Enter the word. Done. Advanced Art Studio has been cracked. We will move on to the letter B now. For this portion of the video, we're going to be taking a look at the game Blades of Steel by Konami. So we have a 1-block boot file, B2, which I'm guessing is a booter, and PW is most likely the password file, because this game does require the user manual to play it. Going to turn on the drive display. All right. Password. There's 1 try, 2 tries, 3 tries, and then it resets. So let's go in memory and see if we can find the kernel routine FFE4, which could possibly be asking for the password. There's nothing. Let's try searching for C903, which is compare number string 03, often used to check if you've tried using your 3 tries at the password. Nothing. So I'm going to disassemble around 3800 because that's roughly where we are. And let's see what we can find. This is not unsurprising. I'm seeing here DC100 and DC01, which is the keyboard matrix. Now you'll recognize it probably as the joystick, but it's also the keyboard matrix. So it's reading keys. 3AEF seems to be where it starts. So let's search for it. There are 2 locations where it calls the keyboard read. 3AEF, we write it backwards. So here we are at 3A79. And this is like a little loop. It calls 3AEO, checks the key BMI. So it's kind of looping around. And then this seems to be filtering. Compare if it's 13, which would be the return key. This is comparing if it is a 0, and if it's branch carry clear, which means if it's less than 0, go back up, because you don't want to be able to input non-numeric values. And this is checking if it's greater than the value after 9. So it's filtering out the value, the keys that you press, and then it stores it at 2C. So just for fun, let's put 1, 2, 3 and take a look at 2C. And because it was written in brackets, it means it's indirectly accessed. So we have to look at BD55. And there we are, 1, 2, 3. So it is storing our password there. So check for key, filter out key, store it, increment 30, which is probably the length of the password, and jump back up. So we want to know where it goes when you press return. It goes to 3AB0, right here. 3B38. Does some arithmetic. It subtracts. Looks like it's converting your number into true decimal. But we just want to know where it's checking. Here's jump FCE2, which is a reset. So this is where it's all going to make sense, right here. We know up here, it's storing your password and looping back up. Here's where it goes when you hit return. And this is where it is converting your password into some sort of arithmetic. What we want is right here. Load 2A compare to 3A14. So one of these is your password, and one of these is the expected password. I'm not sure which is which. And the reason we couldn't find the compare 3 is because it's decrementing. So if we look at 3A17, it's probably going to be a 3. So instead of going 0, 1, 2, 3, we kick you out. It goes 3, 2, 1, and then it kicks you out because it's decrementing. I just got to get back here where we were. Yeah, so right here. If it's not equal to what it wants to see, go here and decrement one of your tries. And there's 2 of them because your code that you enter is more than likely being split into 2 values. So if the code is supposed to be 1, 2, 3, 4, the first one will be 12 and the second one will be 34. So if we want to crack it, what we do is we change 3AC1 to a 60 and just make it RTS. Return. Skip all of this because it returns when it's done anyways. And we'll enter anything. And it works. I'm going to guess that the file we're looking for is PW, short for password. It appears to start at 0C100 and ends at 3D00. So let's go in and apply a permanent fix to it. 60. So it's just going to RTS instead of comparing our password. And I'm going to call it, just going to call it ABC as a temporary name. Copy. Do a hard reset. Refresh, and let's see if it works. All right, 1, 2, 1, 2, 2. There we are. We now have a cracked copy of Konami's Blades of Steel, and it just took 1 byte at 3AC1. Let's move on to Game C. The next program I'm going to look at is Canadian Tire Auto Mechanic by Batteries Included, 1984, so it's quite outdated. We have a 2-block loader file, and if we look at the disk using DIR master, you'll see that track 1 is full of errors. Track 16 is full of errors. So what we're going to do is we're going to use the Vice emulator, because Vice allows you to load files into the monitor right from the disk image. As you can see, I've typed L for load, loader, device 8, with the Canadian Tire disk attached. And it loads from 0100 to 0253. So this is a self-executing program. You load it, 8, 1, and it starts. So let's have a look and see what it's doing. It's doing a JSR to 015B, which is opening a file at 01, Y is high, 015A, 1 character in length. So it's opening a number sign, which is a buffer. And then it is setting FE to BF and FD to FE. Let's bring up the notepad. We need some clarity here. So FD is going to be number string FE. And FE is going to be set to BF. It's doing this for the purposes of indirect addressing. So if you were to put load FD, Y, you would actually be saying load BFFE. When you do a load in brackets, it doesn't load FD. It doesn't load the number FD. It doesn't load what's in FD. Just remember 2 brackets, 2 locations, 2 for 2. So what it does is it goes to location FD, and it takes the 2 bytes and uses those instead, known as indirect addressing. It sets device 15, which is the disk drive, as the default device for output, and then it loads Y with 0, and it loads 014C, Y, and prints it. Instead of printing to the screen, it prints to the disk drive channel. So we take a look at what's in 014C. Lo and behold, we're reading in track 23, sector 7, via a U1 command. If you've done any basic programming with the disk drive, you'll know that U1 is to read in a disk sector. So what it does is reads in track 23, sector 7, and it stores it at FD bracket Y, which is going to be BFFE, because we know it set it to BFFE. Why is it BFFE? That seems like it's a wrong location. Well, the reason for that is that the first 2 bytes of a sector point to the next track and sector, so that the 1541 knows which link to follow. It knows how to follow how to traverse the sectors. So it will read in the next track and sector, go to BFFF, and then finally C1000, where it jumps C1000. So it is loading information from 23.7 and storing it into C1000 and then executing it. So now we're going to switch over to CCS. I'm going to go into 64, into our tool disk, and load Disk Doctor. Then we're going to attach a copy of the disk. I'm calling it Canadian Tire Crack. The difference between Canadian Tire Crack and Canadian Tire is simply that one does not have disk errors on it. So let me show you. I'm going to open Canadian Tire Crack. We're going to view the BAM. I haven't taken the errors off of track 1.
A few moments later.
You can see that the original Canadian Tire disc has errors on track 1, errors on track 16, whereas the Canadian Tire Crack version has no errors on the disc. So I'm going to attach, and we're going to see if it works. I don't expect it to because it doesn't have the disk errors present. And it has crashed, which is to be expected because it's not a legitimate copy, correct? We're now going to load Disk Doctor by Kevin Pickle. And we're going to go back up and we're going to attach the crack disk, which is not cracked yet. It just doesn't have disk errors. And we're going to see what information it is loading in from track 23, sector 7. U150161. 16.1 has an error 23. So let's put it in perspective. Load our auto boots and loads track 23, sector 7 into C1000. Then it jumps to C1000. And that's where the protection lies. You see these first 2 bytes here? Let me turn off my joystick. First 2 bytes are 23 and 17. We're currently on 23.7, the link 23.17. So the first 2 bytes are pointing it to the next sector. And that's important because it was originally set to BFFE, because it's going to skip BFFE, BFFF, and this is going to load in at C1000. And this is the start address, 49152. Let's go in and disassemble the screen using Alt-M. And we're just going to look at what's on the screen. We're seeing machine code because, of course, what's displayed on the sector is visible on screen memory. So it's just an indirect way of being able to edit what's on the disk through the Disk Doctor. We could use it using other means, such as disk scan, but this way is maybe a little bit more efficient. So it's opening a file at C094 that's 1 character in length, which is probably a buffer. It's calling FFE4, which is, here it's setting device 15 as the default device, and then it's getting a character. So that will be reading in the first byte of the disk error. It puts it into C091, and then it reads another one and puts it at C092. So if the disk error is 21, it will be reading in FFE4, which pulls in the 2, FFE4, which pulls in the 1. Because we've tried to read a sector with disk errors, it's not going to pull any information from that sector. It's just going to result in an error. So C091, C092 should be equal to 2 and 1 if we want this game to work. And lo and behold, load C091 compared to 32, which is Petsky for 2. If it's equal, good copy, go down to 5F4, load C092, compare it to 1, branch equal, 5FE, good copy. Now, these are not the actual values, right? If you're looking at 05EO, again, this is screen memory. So the branch equals and branch not equals are going to be compensating because it's screen memory. When it's up at C1000, it'll be totally different. In order to crack it, let's just change this to an AD. So instead of jumping to C155, it just loads C155 and replace this one. So if you had the original disk, it would be a 32. It would be a 2-1 error. If it's not, if you've copied it, it's just going to load C155 and fall through without jumping, where it would crash. Exit, write it back to disk. And now we'll do a reset. And where it crashed before, I'm hoping it works. I don't think anyone will actually use the program. It's decades old, but there we go. We have successfully patched the Home Organizer Auto Maintenance Program by Canadian Tire. It would have been fun working on this program, I think. Being a Canadian product. And there we have it. So that takes care of C. Now we move on to D. Moving on to D, we're going to take a look at Donald Duck's Playground by Sierra Online. Donald Duck's Playground is a regular 35-track disc with 2 disk errors on track 2, sector 15, track 3, sector 16. BB is most likely, it's a basic loader. So it loads COL, which is colors, screen, which is a loading picture, and then it loads Z and calls SYS 49152. Let's get into it in basic. So it puts the border black and the screen black. A is 0 as soon as you type run. If A is 0, then A is 1. Load color, 8, 1. When you do a load from basic, it re-executes the program. So now that A is 1, it loads SCR, and then it re-executes. A becomes 2, it loads Z. A becomes 3, calls SYS 49152. We can recreate this by loading COL, which I'm assuming is some sort of color. SCR. Let's try that again. There we go. Kiosk presents Donald Duck's Playground. And then we get into the Z file. And this is a little bit nasty in the sense of what it does. So the file loads into C1000. If we go into it with a monitor, and by now you should know, I shouldn't have to keep repeating myself, it's Alt-M under CCS, Alt-H on your device. We're going to go into the monitor and disassemble at C1000. And this is what it does. It closes all of the channels. It sets a file name, COF3, which is the number sign. So it's creating a buffer, opening 5,8,5 for that buffer. FFBD is, I believe, the file name. So COE7, Y is the high address, X is the low, so high, low. It's calling a block read. A is the length of the file name, so 12 characters long. So we have 8, 9, 10, 11, 12. A block read, track 2, sector 15, which just so happens to be the disk error. Then we go to CO24. It's opening 15, 8, 15. You can see where this is going, right? And then it calls C0C1, which does a JSR FFCF. It sets the default device to 15, gets a character. So it's attempted to, it opens a buffer, and then it tries to read in the sector with the disk error. Then it opens the disk error channel, 15, 8, 15, gets that character, multiplies it by 2, 4, 8, 16, and puts it in C11C, gets a second character, ands it, ORs it, pushes it. So what it's doing is it's reading the disk error, which should be an error 23. Compare it to 23. If it's not equal, go to CO85. Otherwise, take what's at COF4 and print it, which is a second block read for track 3. So it reads in both errors. And I think it's probably going to do the same thing. Compare the 23. If not, go to CO85. And then finally, it sets a new file name, 7 characters long, at C115, which is Donald star. So it goes to load in the actual game. And then jumps to 811. So what does it do if you don't have the original copy? Well, the first thing it does is it loads A with EA. EA is a no operation. It's a NOP. It does absolutely nothing. Just does 0. Stores it at C1000. And then it starts to erase this by storing it at CO89, CO8A. So it's overwriting this whole routine. But then what it does is it sets channel 15 to the drive as the default, and it prints this message, not to the screen, but to the drive. And this is where we get into the nastiness. N0: pirate disk, GS. So it formats your disk if it doesn't find the errors that it's looking for. I told you it was particularly nasty. I remember back in the day where it would do the same for me a few times. So patching this is really not going to be all that difficult. All we have to do is really make use of these 3. We could put it here, but I'm going to put it right here so it closes out all of the devices at C1003. Where are we going to make it jump to? So this is the first error check. I'm sorry, that would be the second error check right here. All right, so right here, CO55. which calls the disk load for Donald. So 3 bytes, we can do it. Assemble the C1000 JMP jump C055. Skips over the whole protection. I'm going to save it z.prg. It starts at C1000 and it ends at C11D. As you can see here by looking at 2D and 2E. This is the end address. I'm just going to put 1 extra byte. Doesn't hurt. And then we're going to switch back over. We're going to go to Donald Duck's Playground. We're going to make a new disk so that we can test it proper. I'm going to copy all of the files over to the new disk without the disk errors. We'll delete the old Z and we will import new Z. Put it in lowercase and let's call it Donald Cracked. It will either format the disk or it will work. One of the two. For some reason, when I copy files over, I get duplicates. I don't understand why. There's a loading page, and Donald Duck's adventure has begun. Just turn on the joystick. Did it format the disk? No. Now, since we have a cracked copy, let me just demonstrate what it would have done. So let's call C1003, which is going to skip over the jump that I put in, and it's going to check for disk errors. SOS 49155. There's no game. What happened to the game? We know what happened to the game. It was a pirated copy. So I'm going to do a reset. It didn't format the disk. I wonder. It was supposed to format the drive. For some reason, it didn't format the disk, although it was supposed to, which I guess is a good thing. The game obviously doesn't work because it's not the original disk. It doesn't have the disk errors on it. But either way, we have successfully patched this one. So it no longer needs disk errors, and it will no longer attempt to format your disk, whether that works or not. And now we're going to move on to the letter E. For the letter E, we're going to be taking a look at Europe Ablaze. According to DIR Master, this disk has a single error. On track 18, sector 18, there's an error 23. What I'm going to do is I'm going to go into the BAM, and we're just going to remove that single error. And we're going to make it error-free with the intention that, of course, the game is going to do something to indicate that it's a pirated copy. So let's load it and see what it does. We have a basic loader, load start, and then SOS 12983. Kick it into warp mode. And I'm fully intending for the computer to reset. and it has reset as anticipated. We'll break into the monitor and load the file start 08, and it loads from 2200 to 77FF. Start is the file that the basic loader loads in first, and we're going to just hunt from 0 to 77FF for E2FC, because FCE2 is the reboot routine. SYS 64738, of course. And it finds it at 43AB right here. So this is the nasty reset. Right before it, we have a GSR 44CD. Let's take a look at 44CD and see what it is doing. It is setting a call to the kernel 4528, which is the buffer, because it's a number sign. When you're reading and writing sectors, you open a channel to the drive, and then you open a buffer. So you have a place to put the information from the sectors. And then it's opening 5,8,5, which is the buffer. And then it is opening 452A, which is going to be right here, the U1 command. So it's reading from, putting it in buffer 5, drive 0, track 18, sector 18, which has the disk error. Then it opens 15,8,15 because it wants to read the error channel. Sets the default device to 15. Loads Y with 40. Calls GSR FFCF to read the error channel, because we're now using channel 15 as default. And we store at 0300, Y. So since Y is 40, our disk error is going to be stored at 340. Close the devices, load 340, compare to a 32, which is going to be the ASCII value, the PETSCII value for a 2, as in 21 error, 21 error. If it's an illegal copy and it doesn't have the error, then of course the result is going to be a 30, which is a 0. See here how we have a 0? And the equivalent value is 30. You just pretend the 2's not there, in other words. So, open 5,8,5, open 15,8,15. Read the error channel stored at 340, 300 plus 40 in Y. And then check 340, is it a 2? Because it has the proper error. Not equal, it goes to 4525. If it is, okay, so this is going to be important. If it's a legit copy, CLC is going to be set. Okay? Just keep that in mind. Clear carry. If it's not, it goes to 4525, which is set carry, SEC. And then it does an RTS. So it comes back from where it was called. The next thing we do is we figure out where this routine is being called from. So it's going to be called from, well, right here, 44CD. 44CD is right here. And then branch carry clear. So remember I said to pay attention. CLC, if it's a legit copy, clears the carry flag. BCC means branch carry clear. So the error exists, this is the carry clear flag gets set, goes down here. Otherwise, it resets. So how do we crack this sucker? Just change this line right here. Just get rid of that jump FCE2, which is at 43AA. So 43AA, we'll just put load FCE2, a single byte. Scratch start. Save start to disk 08 2200 77FF. And we hope that this one works. There we go. So we have cracked Europe Ablaze. Designed by Roger Keating, Eric Baker, Ian Trout. Copyright 1985. And now we move on to F. For the letter F, we're going to get into the game F14 Tomcat by Activision. This is going to be a little tricky in the sense that the protection is not the usual password. So we're going to load the first file on disk and see what happens. We're going to kick it into 500% speed mode. Activision presents a dynamics production. F14 Tomcat. So I initially thought that this was part of the game where you were able to select what you wanted on your fighter, but I realize now that this is the protection. So what happens is a certain part of the fighter has an arrow pointing to it or something flashing, and you have to select what it is. And to do that, you refer to the user manual. So this is going to be what looks to be an AIM 120 AMRAM. I'm going to make a freeze, and I'm going to show you what happens if you get it right and if you get it wrong. So I've apparently selected the right item. And we're able to enlist, continue career, or fly mission. If you get it wrong, you're asked to sign your signature, and you are discharged from the military. You're hereby discharged for conduct on becoming an officer. So the traditional method of trying to find the password is not going to work in this case. Let's go into the monitor using Alt-M, and we can see that it is executing at 6657. So let's go around 6500. So it's executing around here. First thing I did was I checked location 10, which appears to be addressed indirectly. 62B6. If we move down a line, 62E4, move back up, location 10, 62B6. I thought this was initially the password. So what I did was I changed some of the bytes, and it turns out it's just the color. So the next step is what happens when you press fire. It's obviously going to check your password at some point. So the next thing is to search. Let's do about 0800 to 7000 for DC00, which is the joystick port. There are two locations, 6AFF and 6B02. So let's take a look at the first one. Load DC100. It puts FF in DC100. It loads DC100, ends with 10, which is a perfect candidate for the fire button. So what I'm going to do is assemble at 6B01, jump 6B01, so it loops. I just want to see if that's the right point, and it's not because the game has continued. Let's take a look at 6B02. Load DC100 and it with 10. So I'm going to put 6B06, jump 6B06 to make it loop back to itself. And it appears that that is also the wrong one. What I'm going to do is type in 033C and number string 10, which is how we get the byte for the fire button. Since neither of those two locations of load DC100 and ending it with 10 were the right ones, I just want to see if I can find and 10 anywhere else. .647C is in and around the area. So here, I don't see any call to the joystick. What I'm going to do is just make it loop back to itself. 6480, jump 6480. Press fire. And we have found the fire routine. So just to go into it again, we hunted for DC100. There are two routines, neither of which was the and number string 10 that we wanted. I then hunted for and number string 10, and then looked in and around the routine at 647C, just on the off chance that this was it, and created this into an infinite loop. So I made it jump to 6480. Exit. When I press fire, it gets stuck at 6480 in that loop. So that's the area that we are looking for. So we now know that 6517 is what happens when you press fire. So it goes to 661D. It loads 6534, compares it with 35. If it's equal, it sets DE to a 0. If it's not equal, it sets DE to a 1. Based on everything that you've learned so far in this video series, this looks like a pretty good candidate, doesn't it? So let's see what it does. Goes to C3A4. Appears to do something with possibly the color. I suppose the easiest way is to just change this 1 byte here, that's 6526, to an EA. So compare the two. If it's equal, go down here. If it's not equal and you get it wrong, assuming that this is the right routine, it will set DE to a 1, but it's going to fall through and set it back to a 0. And let's just see if that works. We'll purposely select the wrong item. And we've done it. We have cracked the protection. It took all of about 2 minutes. So now comes the fun part, trying to find out which one of these files is the correct one, and hope that they're not encrypted. If it's encrypted, well, that's going to take things all to a different level. I'm loading in each file one by one and checking the end address at 2D, 2E, which is the pointer to the end of the file. And then I'm checking to see if the code exists that we're looking for, thus indicating it was the right file. And if it is encrypted, then we're going to have to come up with an alternative solution. I thought I would spare you the process of going through all of these files. I eventually found it in the very last file, OB. What I'm going to do is I'm going to fill the memory with asterisks, as you can see here. And then I'm going to load OB, comma 8, comma 1. And then just see where in memory the program starts and ends. So it starts at 6400 and it ends at 6800. Take a look at 6526. It's loading this value, comparing it with this one. If it's equal, it goes down here. Good code, otherwise bad code. We're going to change 6526 to an EA. And that will do it. Save OB 6400 to 6800. We're going to load our dir master. F14 Tomcat side 1. Delete OB. File import. Go into my CCS folder where the file is saved. OB, I'm going to rename it to a lowercase OB. CCS64, the emulator that I use. When you use SP, it saves the file not onto a disk image, but it saves it to the CCS folder. I'm going to resave that over top of itself. And now we're going to see if the crack works. Okay, we have a flashing fellow refueler crew. I'm going to assume he's an oil cooler intake. Press fire, and the game allows you to play. So we have now cracked F14 Tomcat. Let's move on to the letter G. For our next game, I'm going to be taking a look at Gauntlet by US Gold. It utilizes a signature on track 40. So unless you have a copier that copies up to track 40, you're not going to be able to get a working copy of the game. In earlier years, this was kind of difficult, but eventually copiers were introduced that would copy up to tracks 40. I'm going to put it into warp mode to speed up the process. All right, let's do a reboot and see what's going on with the custom loader. I'm going to break into the monitor using Alt-H under Vice and examine 0300. We can see here it loads 0 and stores it into 0. Then increments 340, which is this part right here. It loads 0300, exclusive ORs it with 330, stores it in 0300, loads 029D, stores it in FC100, loads 0504, exclusive ORs it. There's a whole lot of encryption in this loader. It loads E1000, exclusive ORs it with 0100, exclusive ORs it with 4C, stores it in E1000, Y, and jumps to E016. And then it loads 0100, stores it into 1000. So this is a pretty complex loading file. Now imagine back in the day when you didn't have emulators and you had to dissect it using just a cartridge. It could be a little time-consuming and difficult. I'm going to set a breakpoint at E1000 because this loader does eventually call it. And you can see that's taking effect right now. And at E1000, it sets 8000 to 3C, 8001 to 03. And then it checks 033C. If it's branch equal to 0, it goes back up to 8000. I'm not sure why it's doing that. 033C. It's almost like it's a pointer. But I don't offhand know why it would be doing that. And it loads E1000, it exclusive ORs it, stores it back into E1000, and does a jump to 1000. We see that there's a jump to 1000 right here. So let's set a breakpoint for 1000 and take a look at what's going on here. It's opening 15, 8, 15. It puts a number 0 at 1097, which now has become a 1. Sets the file name for 1096. Number 1. So it looks like it's opening a buffer. And then it sets device 15 as the default device. Loads 1088, Y. So it does a block execute, track 5, sector 5. It's a pretty complicated loader. And then it does a jump to 0330. Let's delete all of our breakpoints and just have a breakpoint at 0330. All right, that is kicked in. At 0330, it opens 2, 8, 2, sets a file name at 03F0 that is 4 characters long. That file name is going to be spic. So it loads spic and then jumps to 2800. It goes through all of this encryption. Let's just take a look at the loader here. Load E1000, store E1000, it increments. Loads 368, which is encrypted. Exclusive ORs it with 0330. Stores it back and then falls through to the encryption. Let me set a breakpoint at 36D. Then it loads 29D, stores it in FC100. This is the decrypted code. This is a complete mess. So they went through a lot of work to encrypt this loader that would go up and check track 40. Now, so far in these videos, you've found out that usually it's just one single byte that allows you to crack a game. In this particular case, the process is actually a heck of a lot easier. We'll load spic, 8, I meant to put 1, but 81 will do. Anything other than 0 has the same effect, 8, 1, 8, 100. As long as it's not a 0, it will load into the start address in the file. And then we'll go into the monitor, look at 2800. 8192 plus 8 times 256, which is 2800 spic. We wait for the disk load to finish. And that's it. In this case, we haven't actually cracked Gauntlet, but we've bypassed the entire loader and protection system. So let's make a little program, even in BASIC. We'll put if A equals 0, then A equals 1, load spic, 8, 1, 20, SYS, and I have to do a little bit of math here. Current 8192 plus 8 times 256, 10240. So SYS 10240, what's going to happen is it's going to run. A will be 0 when you type run because all your variables are cleared out. It sets it to 1, loads spic. The next time it comes back, it does the SYS. 2 lines of BASIC. And then we're going to scratch the old file. Seems to have worked. Save 0 colon Gauntlet, 8. We could do this in machine code as well, but let's keep it simple. Okay, that is done. We'll do a hard reset. Load the first file on disk. It's not checking track 40 any longer. It's just loading spic. And the game works just as if it were the original disk, which it still technically is, but we've bypassed the loader. And there we go. So that was an easy one, despite being a very complex loader. The only thing is, if the game ever decides to go back and load the loader back over again, it's going to be calling our one from BASIC, so it may or may not work. And now we're going to move on to H. For the game H, we're going to take a look at hard and heavy. Now this game is protected, and if you try to load it under CCS, I'm going to show you what it does. So I tried loading it under CCS, and it reset the machine. And furthermore, it did this to the directory. It corrupted it. It only works under Vice. There are 3 main files, reline, A, and B. So we're going to go into the monitor right about now and see what it's doing. So at around 200 and B1, it's doing a disk load, 6-character file name at 8000D, which is reline. So it loads reline, and it looks like it just runs it. So the problem with this game is that all of the files are encrypted. It does a series of exclusive ORs, which means that if we want to crack the game, we're going to have to use a couple of unorthodox methods. What I'm going to do is just reset the computer. And I'm going to load the game right up until about the point where it's going to run. We're just not even going to bother with this loader. Okay, so it has executed on a breakpoint. We see here it jumps to 820. Now the title page has come up. I go back into the monitor, and it's at 84C. So if we disassemble around 0800, you'll see here, it copies some code to, looks around D1000. It takes a 0, puts it in C6, loads C6, branch equal 84A. C6 is location 198. That's the keyboard buffer. So every time you press a key, the keyboard buffer increments by 1. What it's doing is it's just checking to see if a key has been pressed. And then it jumps to 090D if a key has been pressed. So let's take a look at 090D. Sets the screen to black. And then it calls a file name at A53, which appears to be F, although there is no file named F. And then it loads from OA51. So it loads file A and B. And then you see here it's doing some exclusive ORing. So all of these files are encrypted, meaning that we can't just load them in and execute them. So just to kind of recap what we've done so far, we've loaded the auto boot, let it go to the title page, and then gone in to examine the code. And we see here that it's loading in some files. It's this JSR FFD5, because X and Y is set, it's setting the start address to 0400. So OA51 the file B. A is 1 character long, so that's the length of the file name. Y is high, so A51 is the file name itself, which is B. FFD5 does the load. Because X and Y is set, it's loading it to 0400. And then it sets FA to 1, FB to 04. So indirect addressing, that's 0401. Switches off the ROM, and then it loads 0401, subtracts 1, exclusive ORs, and stores it back. So it's decrypting. Basically, we're screwed. That's what I'm saying. So we're going to have to set a breakpoint right here at 0600, which is probably the final jump right before the game starts. So I've created a breakpoint. I'm going to exit, and we'll just let the load process continue. And our breakpoint has executed, so we know that it tried to execute 0600. Now would be a very good time to try and save this to disk. Looking at the code, we see a JSR 0401. We know it loaded into 0400. So we're going to have to save from 0400 and up. Now that the game has loaded and our breakpoint is kicked in, what I'm going to do is I'm going to bank out the ROM by filling location 1 with 34. Then I'm going to save to a blank disk, RIP, device 8, 0400, because we know it started loading at 0400, to FFFF just to be safe. So we've saved it all. It went up and it checked track 36, and you can see it is doing something to the tracks, trying to totally wipe them out. We might have just trashed the disk. Let's see. So as you can see, cannot read image contents. It trashed the disk. We're going to have to redo this again. So here we go. This time, however, read only. This game is proving to be a pain in the ass. All right, now we're going to go into the monitor. We're going to keep that breakpoint at 0600. That's all you need to know for now, is that you set a breakpoint typing in break 0600 because we want to stop the main game from executing. Just load the boot file, hit space, and wait for it to finish. That's going to be step 1. Step 2, do not let the game continue because it may just trash the disk. All right, we are now on step 4. Step 4 is get a new disk ready, but do not type X from the monitor because if you do, it's going to continue and trash the disk. So what I'm going to do is I'm going to create a new disk. I'm going to call it hard and heavy crack. I'm going to overwrite it because it trashed the last one. And I have to do one more thing. I was wondering why I couldn't save the file. Then I realized it was set to read only. So now we are playing with fire. If we exit, it's going to continue executing this code. So we have to find the protection. This is where the game starts. It sets location 1 to 37. It calls FFBA, which opens a channel. FFBD is a file name, 3DBC. Remember, Y is high. So it loads ATG, 3 characters long, A is 3. So that's going to be all-time greats, the high score. Then it goes to 0401. 0401 does a JSR. Now, if you've been watching my video very closely and you've been paying attention, you will know that when there's a JSR followed by a BCC, it could be a sign of protection because it could be setting a flag. But I want you to just to follow this through. Okay? It JSRs to some routine. What the routine is just yet, we don't know. It goes to another routine. What that is just yet, we don't know. But we know if it comes back as the carry clear flag being set, it goes to 041C and exits. Okay? So that's one door. The other door is it goes here and loads 041D, X, which is here, and stores it at 0100. So it's copying from 041D to 0100 and then jumping 0100. So it's putting this routine into 0100 and then firing it. What it does, it deletes 0200, deletes 0300, 400, and 500. And then it puts 37 back into 1 and jumps to FFFC. FFFC in brackets. Remember from the video, 2 brackets, 2 locations. We go down to FFFC. It's FC, high byte, E2, low byte, FCE2. So this copies itself to 0100, trashes memory, and then does a system reset. It probably puts it at 0100 because that memory is cleared when the system is reset. So this is probably, I'm going to say without a doubt, this is our protection. And if we take a look at 474, it's calling 0503. And I see here it's calling, it's loading ISO 6, it's taking 463 and calling FFA8. FFA8 is synonymous with writing to the disk drive. And you see here we've got a memory write, it's backwards, and a memory execute. M take away E, M take away X. Because what it's doing is it's loading Y with 4 and decrementing Y. So it's going in reverse order, not incrementing. And if you look at 46A, memory execute. So what do you think the odds are that it's trashing the disk? In order to crack this game, this is what we're going to do. This is what you're going to do. Load the boot file. Set a breakpoint for 0600 when the picture comes up. Wait for the game to load. Get a new disk, put it in the drive. And then you're going to bank out ROM. I'll show you how to do that. And save 0400 to FFFF. 0400 because that's where it starts in memory. So we look at location 1, it's a 37, fill 0101 34. Fill from location 1 to location 1 with 34. So that now A1000 is not Commodore Basic, it's RAM. E1000 is not kernel, it's RAM. We get everything. And we will just call it RIP 0400 to FFFF. Okay, I think that took effect. Let's have a look here. Okay, so it's 254 blocks. That is huge. But it ensures that we have everything. And we already know that the start address is 0600. Oh, but we forgot to do one important thing. Milosoft, you forgot something. What did you forget? Yeah. We forgot to actually crack it. I forgot to crack it. You probably remembered. Right here. At 0621. Let's get rid of that. Assemble at 0621. Nop. So it does absolutely no operation. Does nothing. We're going to scratch everything. And we're going to save rip. Done. And when I come back for the second half of this video, we're going to try compiling it and seeing if it works. For the next step, we're going to use dir master, and we're going to go into the folder that has the disk image with the rip on it, and I'm going to export it to my CCS folder. Actually, I don't have to. We can make a new folder here. Let's just let's make a new folder called H&H. Sounds like a record store. All right, so now we've saved it to a disk image, and now we extract from the disk image to a folder, the main file. So if I go cd H&H, there is our 64K file called RIP. And now you need a copy of Exomizer, which I just happen to have here. So put Exomizer in the same folder as rip.prg, assuming you called it RIP. Exomizer SFX, which is the type of compression we want to use. The start address 0x, and then the hex address 0600. File name rip.prg. Output file name -o hard heavy cracked.prg. And it's going to go from 0400 to, I don't know why it's saying 10,000. It should be FFFF. And now comes the true test. It wouldn't run in CCS before. Let's see if it runs in CCS now. H&H, hard and heavy cracked. Just seeing that it is decompressing, and it appears to be. And there we go. It plays. It didn't reset, and it didn't trash the disk. And just for fun, let's import it back in. So the original file was 254 blocks. The cracked one is 145. Pretty good compression. And that's how you crack hard and heavy. Oh, but we're not done yet. No. We are not done yet. There's one other issue, and I released a fix for it. Do you know what that issue was? Well, I'm going to show you. So if you look at location 328, 328 is the run stop disable. It's set to ED, which is 237. It's supposed to be ED. That's perfect. That means that you can run stop restore the game. If you load the original game, hard and heavy, one of the first things it does, let me just show you, it sets 328 to EA, so it disables the run stop key. Okay, so you're thinking, well, what's the big deal? I'm going to disable writing so that create a breakpoint. So we're gonna do a really quick crack of this one just to show you what the issue is. I just love how this monitor just takes on a life of its own sometimes. Okay, so right here we disable that. Okay, so we're going to play a game. I'm going to make sure that we have a disk attached. And we're just going to play a game. Okay, so the game is over. I'm just going to turn the sound off. And I'm going to put in my name. Press enter. Press F1 to save high scores. All right, saving. Okay, so we should have a copy of the high scores on disk. Oh, shit. I forgot to do that. All right, so let's play another game. And I'm just going to put in Wii. And I'm going to press F1 to save the high scores. Okay. Now we have the high scores on disk. There they are. And you can see that the high scores are good. There's nothing wrong with them. All right. Now we're going to do a reset. We're going to load the game back in. I'm going to set the same breakpoint so that we can give it a quick 2-second crack. And then we're going to crack it again. And I want you to watch something. Okay. Look at the scores. They're corrupted. And the reason they're corrupted is there was a bug in the original game. And the bug is you cannot set this to EA. You cannot have it at 234 and use a save in the kernel. It corrupts the save routine. So the game itself was bugged right from the original disk. And if you go on my itch page, I'll put a little link in the description. There's a patch I made that will fix that for you. So we've now successfully fixed the high score bug by getting rid of the run stop disable, and we've removed the protection. So we'll see you on the letter I.